Hello, good day viewers. Welcome to another mathematics presentation. So we are still looking at the logarithms, and this is our third lesson. So in today's lesson, we are going to concentrate on the laws of logarithms. Okay, so we have quite a number of for the laws of logarithms. So we are going to start with the first one. So this one will focus on the product the product rule. Okay, so this product rule for logarithms, what does it state? Okay, so for this one, in case you have log, okay, base a, then mn, so meaning that these two values are multiplying each other. So the interpretation of this product rule is that the logarithm of a product is the sum of the logarithms of the individual factors. So these individual factors m and n, you can add them. So this one will be written as, you write log m in base a plus log a in base n. So it will be translated into this way. Okay, so this is what the product rule states. Okay, so let's look at an example. So this is our example. Expand log, we have 9x squared y in base 3. So we need to expand this one. Remember, here we are finding the product of this. So we are saying the product of this log, it will give us the sum of the individual factors of this. So the way you can expand this one, so we are going to write what we have been given, log in base 3, then we have 9x squared y. So this one, the way we are going to expand it, so we'll say log 3, then we get this 9 plus, okay, again we say log 3, then we get this x squared plus, again we say log in base 3, then we get this y. So we need to find the sum of these individual factors, okay, which will carry the same log with the same what base, like this. Okay, so I hope this is clear. So from here we are just expanding. Okay, now if you want to solve it, we can now simplify. We can simplify this log 9, which is in base 3. Okay, we can simplify this log if you want. Now I just wanted to show you how we can expand, but look at how we can solve them later on. Okay, all right, so I'm sure, let's just simplify it. We can expand. So this is what we have. So we have log in base 3, and then 9 plus log 3, and then x power 2 plus log 3y. So we can take note of, remember I've said we can simplify this one. Okay, we can simplify this one, and we are going to use the power rule. We can say we're going to use the power rule. This is another rule now, and I've said number 2 here. Okay, so the way we are going to apply this one is this. You can see that here I will take note of this. Okay, so if you have something like you have log 9 with a base of 3, so we know that 3 squared gives us 9. Okay, so I'll write this one in this way. So it's going to be like this. It will be log with a base of 3, then 3 squared, because 3 squared gives us what? A 9. So we are applying the power rule, where we can take these two to multiply with the log. So this will be 2 log 3, then this 3. Okay, so for this one it will be written like this. Now again, from here we understand that if you have log a with a base of a, this will always give us what? 1. Okay, even if you have log let's say 6, the base of 6, still this will give us what? 1. As long as the base here and the log number is the same, to give you 1. Okay, so this one right here, log 3 with a base of 3, to be a 1. So we are going to write this one now where there is this, supposed to put this one. Okay, so we are going to say 2 log 3, then 3 plus, then for this one right here, again we apply the same principle where I said these 2 come in front. So this power 2 in front of the power of x, these 2 will come right here. So plus 2, okay, then log 3x, then plus log 3y. I hope you are following. So from here, remember what I've said, this one to be a 1, okay, so it's just 2, this one will be a 1, so it's just 2 plus this 2 log 3 then x plus log 3y. So this is the expanded one. So if you have observed right here on number 2, I've explained on the power rule as well. Okay, so we now move on to another rule. All right, so we now come to the quotient rule. Okay, so the quotient rule now, if you have log m over n with a base of a, this one. So the quotient rule states that the logarithm of the quotient is the difference, okay, is the difference of the logarithms of the divided or dividend and the divisor. So we have the dividend and the divisor, so we're going to find their difference. So this one, you can write it as this log a, then you get this m. We are saying it's the difference between the dividend and the divider. So minus log with a base of a, then you write what, n. This is how you can expand it. Okay, that is how you can expand it. All right, so this is our example that we have. So we need to expand this one. We have log with a base of a, then x squared over z. So this is what we have. So you're saying when you are looking at the quotient, okay, the quotient of the log, we find the difference between the divider, the dividend, and the divisor. So this one will say log with a base of a, so we get this x squared. So it is the difference between this and this, minus, we get the same one, log with a base of a z. Now for this one, remember whenever we have a power here, we are going to apply the power rule, where these two will come right here. Okay, so this will be 2 log a x minus then log a z. So this is how we can leave it. So make sure that you are following through these rules. They are very important, because when we start looking at solving logarithms, we'll be using the same rules. Okay, that's why it's very cardinal that you understand these properties. All right, so we now come to another rule. So this rule is involving the change of the base formula. So for this one, you must know how you can change the base of a logarithm. Okay, you must know how you can change the base of the logarithm. So for example, if you have log with a base of a, then you have m. Okay, so you need to know, first of all, you must know that we have what we call a common what? A common base. So this common base, okay, this common base is base 10. So if a log is just like this, you know that this log is in base what? Is in base 10. Okay, it is in base 10 right here. You can put a 10 if you want, or to just be written like this. You know that this is in base 10, so this is a common base. Okay, so if the base of the logarithm is omitted, then that's when you must take note that it is in base 10. Okay, examples, if you have log 6, you know that, oh, this log, the base is a 10. Okay, that is the information I wanted to share with you. So if you are changing now the base of the log, okay, for example, you have this log which is in base A, M. So the first thing that you do, okay, if you want to change, let's say we can say we let X to be equal to this one that you have been given, then M. So we have X equal to log in base A, then M. So I want you to follow me nicely here. So this is what you have. Now, how do you change this? So this is in log form. You are going to change this into what? We are going to change this into exponential form. So you recall that if you want to change this into exponential form, this base will maintain. So you have A as a base. Okay, you have A as your base. Then this you have A as your base. Then this X will be the power like this, then equal to this M. This is what you are going to have, not so? Okay, then from here, you can apply the power rule where you say you can introduce the common base, which is the base 10. So we introduce the common log like this, log, then A, X equal to again here log, then M. Then from here we apply the power rule where this X will come this side. So we have X log, okay, X log, we have right here equal to log M. So you can divide this, you say log A, again you divide here by log A. So this and this will cancel. So we are going to have X equal to log M over log A. So it means you have here you are now changing the what? The base of the log. Okay, you are now changing the base of the what? Of the log. Okay, now here remember that these values MA, they should not be equal to 1. Okay, so let's look at another example. Let's say you are given to say, can you evaluate? They are saying, can you evaluate? Okay, can you evaluate log 2, which is in base what? 7. Can you evaluate this one? Okay, so in order for you to evaluate this one, you are still going to do the same. So we are going to say we let X be equal to this. We say log 2 with a base of 7. So this is X equal to log with a base of 7, then 2. So from here, what's next? Remember I said that the base of this log is in base 7. Okay, so you need to rewrite this from this form to exponential form, of which you know that this base 7 will maintain, raise to the power of x, then equal to 2. This is what you have. From here, introduce the common what? The common base, okay, which is log 10. Log 10, then write 7 power x equal to log 10, okay, like this. Then this x will come this side. We're using the power rule, so we have x log 7 equal to log 2. So this is base 7, base 10, base 10. So from here, we can divide by this log 7, even here, log 7. So we can cancel this and this. Then you get x equal to, you have log 2 over log 7. Let me, in case you can't see clearly. Right, so now this means that if you, what you are given this this one. So this one is equal to this, which is log 2 over log 7. So you can even press on the calculator, since the question was saying can you evaluate. Okay, you can even press on your calculator to see what you are going to get. Right, so on your calculator, this is what you are going to get. Okay, the question is saying evaluate, so you can just write your answer. You say 0.36 like this. Just leave it correct to 2 decimal places. Okay, so let's look at one example also. Let's look at another example. All right, so here is another example. So I want you to understand again on this example. Change log 7, which is in base 5, to base 7. So they want us to change to base what? 7. Pay attention. So you can introduce, let's say you introduce x equal to this, which is log with a base of 5, then 7. Okay, so from here you can rewrite this, okay, in exponential form, which will be 5 power x equal to what? 7. So now the base number that they want you to change is to base what? 7. So if you are changing to base 7, you are going to introduce here the same log with the same base number. So I'm going to say log, which is in base 7, okay, then you write 5x equal to log, which is in base 7. Then you write what? 7. I hope this principle is okay with you. You have understood. So from here, you can remember that I did mention that if you have something like this, you have log with a base of again a, this will give you 1. So you can notice what you have here. It's the same thing. So this side it will be a 1. Okay. Then on the left hand side, you can apply this power rule. You would take this x to be here, x, then log base 7 and the 5. So we want to say we divide by log 7 with 5, okay, then this side with log 7 and the 5. I hope you have seen what I've done here, okay. I hope you have seen what I've done here. So now this one, when you cancel this and this, it's a 1. You just remain with x. Okay, you just remain with x equal to 1 over log 5, then you write the base, which is a 7. So we can now say, therefore, okay, they wanted us to change log with a base of 5, 7 to base 7. So this is our answer, this one, right? 1 over log, which is in base 7, and the 5. So this is our answer. Okay, this is our answer. I hope it's clear. Okay, I do hope that it's clear. I hope it's clear. So let us now look at another rule. Okay. All right, so let us now look at the zero rule. So the zero rule, what does this rule state? So the zero rule, you say, for example, if you have log with a base of a, then you have a 1 right here. Okay, so for this one, to give us a what? A 0. So what it means is the logarithm of 1 to n base, it's always a what? A 0. The logarithm of 1 to n base is always a 0. So for example, if you have log 7, then there is a 1 here. This will give us a 0. Again, if you have log 6, then there is a 1 here. It always give us a 0. Or if you have 8, then there is a 1. It will always give us a what? A 0. So you must know this rule, the zero rule. Okay? The logarithm of 1 to any base is always a what? A 0. So I hope this one is clear. Let us now look at another one. All right, so let's look at the identity rule. Okay, identity what? Rule. So under the identity rule, let's say you have log a. In fact, this one I've even talked about it. Log with a base of a, then it's logarithm of a again. Okay, log of a with a base of a. We have said this will always give us a what? A 1. So the logarithm of a number, okay, to its own base, it's always a what? A 1. So if you have log of 10, again here there is 10, it's a 1. If you have log of 5, again here there is 5 log 5, and in base 5, it's always 1. Okay. If you have log of 100 in base 100, it's always a 1. That is the identity rule. Okay. The logarithm of a number to its own base, logarithm of the number base, the logarithm 10 to the base number of 10, again it's a 1. Okay, so I hope this one you have understood. Then let me also just talk about the inverse logarithm property, of which I've also explained it. Alright, so we are now looking at the inverse logarithm property. So for this one, let's say you have something like this. You have log, and here there is a, again here there is a, and this log a with a base of a. So this a will be raised to the power of what? Of x. Then we say this one is equal to x, because we know that for this property we are saying if you have a log of a number and it has the same base, okay, this is a 1. So no wonder here we are going to put a 1. So 1. Okay. So now this x, it will be equal to this x. So let's say if you have something like this. So we have something like if we have a raised to the power of this, okay, log a, then we are going to have x right here. So even this one will be equal to what? To x. So what we are applying here, we are just applying this property of 1 to 1. So we can say that this property now, it shows the inverse relationship between the logarithms and the exponents. Okay, that is the relationship that it's showing. Okay. So for this one, what has happened here is that since we are using the inverse logarithm property, so if we have a here, then we have log with a base of a. So this and this will cancel, remain with this x equal to x. So this is where I'm saying when you're looking at this inverse logarithm property, we are saying it shows the relationship, okay? It shows the relationship that is existing between the logarithms and the exponents, okay? It shows the inverse relationship between logarithms and the exponents. So for lesson 1, we can end here in for lesson 3. Yeah. Then for the next lesson, we are going to look at more questions that have to do with answering, solving logarithms, evaluating, where we are going to apply all these properties that we have discussed.